Good evening, students. Today we'll start the class with the topic state variables. Okay, so first let us see what the state variables mean. Variables like pressure, volume, temperature are called state variables or state functions because their values depend only on the state of the system and not on how it is reached. Okay, so here I would like to give you an example. Suppose you consider ice. The ice can be converted to water. Either you have to heat it, or if you keep the ice at room temperature, then also it will be converted to water. So our matter of concern is not how you have converted the ice into water. Either you can heat it, or even at room temperature it is going to change, right? So our matter is not concerned on how you have obtained the states. Our matter is concerned only on the states of the matter. We will study only about this ice and the water. We are not going to study how you have got water from ice. And as you can see, the topic is state variables. Variable means any value that changes. Okay, so that is the variables. And state variable means what? This pressure, volume, temperature is given as an example. So these three are the variables because this will change when you will convert the ice into water. At state ice, when the water is at ice condition, or it is solid, then what will happen? The pressure, volume and temperature will be very different from that of the water. So that is why it is called as state variables or state functions. Next is your internal energy. What do you mean by internal energy? So actually internal energy is an example of state variable. Okay, so besides temperature, pressure and volume, you'll also get some other functions which are state variables. So now let us see what do you mean by internal energy. In a body, there can be potential energy, there can be kinetic energy, and there is chemical energy, electrical energy, mechanical energy. So all these energies are stored inside the body. So the sum of all these energies in a system is called the internal energy, and it is depicted with a capital U. Before we move on into more details of the chapter, we have to know that in thermodynamics, you will get the terms like adiabatic, isothermal, isobaric or isochoric. So these are the processes. Okay, so what are these actually? Let us see. So adiabatic is a process in which there is no changes of heat. Okay, so there is no change in the heat. Then in isothermal, what happens? There is no changes in the temperature. Isobaric, there is no change in the pressure. Isochoric, the volume remains constant, or there is no changes in the volume. So you have to remember these processes along with the denotions. Okay, so isobaric, you can remember like barometer is used to measure the pressure, right? So that is related to isobaric. Then isothermal, thermal related to temperature. So these two you remember. Then adiabatic is heat, isochoric is volume. So these processes you have to remember. Okay, yesterday we have discussed about the types of systems, and there you have got one word, that is exchange. So this word exchange is applicable only between the system and the surrounding. Whatever was exchanged, that is matter and the energy, thermal energy. So this exchange was taking place between the system and the surrounding. So here one thing you have to remember: when heat is transferred from surrounding to system, the heat of the system will increase, it will become positive. Okay, and heat, it's depicted with small q, so you have to write plus q. If heat is going out of the system, here it will be minus q, and here it will be plus q. So the word exchange, or going out and coming in, so these words are applicable only between the system and the surrounding. If anything is lost from the system, it will always move on to the surrounding, and if anything is lost, then it will always go to the system. So these two are very important, and every time you will not get the word surrounding whenever it is said that heat is lost, so that directly means heat is going out to the surrounding. Okay, so this thing you have to remember here. And yesterday we have also learned the word system. It is that part of the universe which we are going to study, right? System. So anything, any quantity we will get now, we will always talk in relation with the system and not with the surrounding, because we are going to study only the system part and not the surrounding. Okay, so whatever quantity we will get, it will be always in relation or in connection with the system. So you see here, Q is positive when heat is transferred from the surroundings to the system. So heat is being transferred to the system, so Q is positive. And Q will be negative when the heat is transferred from the system to the surroundings. Okay, but if we talk about surrounding, you know it will become opposite, because you see here, to the here it will be from the surroundings, so it will, Q will be negative, right? And here it will be positive. But we are not about to study the surroundings, we are here to study about the system. So the quantity is about the system, not the surroundings. The next question is, what is heat? So it is the exchange of energy which takes place as a result of temperature difference. Okay, so and it is depicted with Q, you already know. So what happens actually, suppose you take an example here, take a glass of hot water and you keep it open. Okay, then after some time, after 5 minutes, you say what will happen? The hot water will turn cool. Okay, so why this happen? Actually the environment, the surrounding, now you can say the surrounding is having less heat and that glass of water is having more heat, so there is a temperature difference. And you know that heat will always flow from the higher concentration or higher region to the lower region, just like water flow from the higher region to the lower region, it flows from top to bottom. So similar thing happen here also. Since the temperature is more in the glass of water, it will always tend to flow towards where it is less. So the heat will be transferred to the surrounding whose temperature was less. And at a certain time, you will get that the water is converted. The water is converted to the normal room temperature. Now you see, after heat is being transferred from the glass of water to the surrounding, at a point the temperature of the glass of water and the temperature of the surrounding will be same. There is no temperature difference now, so there will be no flow of heat. So after say 1 hour, you will observe that the glass of water is the normal room temperature. That is why whenever you have to measure the temperature of the environment in the labs, you always have to take a glass of water, keep it for some time, and then you can put a thermometer there, you will get the room temperature. So this is how heat works, and this is the reason why heat flows from higher region to lower region, and at a point you will get equilibrium, means equal temperatures, and at that equal temperatures you will get the same temperature. Okay, sorry, same heat flow will be same from the surrounding to the system and system to the surrounding. So this is another topic which we will study later on, and that chapter is called equilibrium. Okay, so we will study that later, and now let us go to the other topic. Here you can see delta U is equal to Q plus W. Delta U, this delta is a sign of the difference. In chemistry, this delta means difference. Okay, what difference? Because you see, we are talking about state 1 and state 2. State variables, right? So internal energy is a state variable, and at state 1, what was the internal energy? At state 2, what will be the internal energy? So there will be a difference in the energies, and this difference is brought about by Q, that is the change in heat. Transfer of heat will take place, either it will the heat will move to the system or it will move to the surrounding. So the heat changes will be there, transfer of heat. And W means work. So the change in energy or the change in internal energy can be brought about by working, by doing work, or by the transfer of heat, and it can be both as well. So we will add both these terms, delta U equal to Q plus W. It is an important mathematical expression you have to remember for solving so many numericals later on. So delta U equal to Q plus W. Now, let us move on to the first law of thermodynamics, which states that the energy of an isolated system is constant. Yeah, you see, in an isolated system, there is a barrier which will not allow the system to exchange heat or to exchange matter. So, heat exchange means obviously it is a form of energy, and you can say that the energy of that isolated system is constant because it is not moving outside the isolated system. And delta U equal to Q plus W is a mathematical statement of the first law of thermodynamics. So this is the mathematical statement of the first law of thermodynamics. Since you know that delta U is a state variable, so will depend only on the initial and final state. It will be independent, means it will be not dependent of how or the way the change is carried out. If there is no transfer of energy, means Q equal to 0 as heat or as work. If there is no transfer of energy as Q or as W, means by working or by transferring heat, then both will be 0, right? W equal to 0, Q equal to 0. Then what will happen? Delta U 0 plus 0, it will become 0. So there is no energy change. That is why we are getting this line. The energy of an isolated system is constant. So this is the first law of thermodynamics. Whatever I have underlined, that you have to write if you are asked what is the first law of thermodynamics, and after that you have to mention this line. In an isolated system, there is no transfer of energy as heat or as work. Therefore, W equal to 0, Q equal to 0, hence delta U equal to 0.